I'm Nitin, and today we'll be talking about Webpack. So, how many of you already know about Webpack? That's quite large. And how many of you have written a Webpack plugin? None of you. Okay. So today I'll be talking about Webpack, and I'll be giving you an overview of how things over the hood, and then we'll dive in and we'll discuss how internally things work. So a quick introduction would be I'm a front-end engineer at Razorpay. I love open source. I'm currently actually helping maintain Webpack and ESLint. So I'm part of core team of both of these projects. And if I'm not coding, so then I'm definitely watching some anime. And you can find me on internet at sritin315. So are you excited? Here's a clip that shows how excited I was last night. Let's dive in. So what is Webpack? So almost all of you have used Webpack. So generally people say Webpack is a module bundler. I like to define it as a tool that lets you write modules in a way that works in browsers. So basically, you write stuff that is nice for you, and Webpack converts all that thing to the stuff that is nice for browsers to read. So what does that mean? So nice for you to write can be like formatted code in multiple lines, logical separation of code in multiple files, or it could be in a different language that browser does not understand. For example, TypeScript. Any TypeScript lover here? Okay. That's quite a lot. So nice for browsers to read could be ES5, fewer requests, smaller responses. So how do we use Webpack? So there are multiple ways to use Webpack. One of them is via the Webpack configuration. So you define all your basic options, entry, output, and then that creates a bundle. We'll dive in later slides. Another way is the command line interface. You can directly specify entry and output via the CLI itself. Fun fact is that almost every config option is supported via CLI except those which do not accept an object. For example, the loaders configuration. We also have a ser command that lets you spin up a development service for local development. And we also expose the Node.js API, which you can directly import Webpack from your Node modules and call the Node.js API to run Webpack. This is how internally some tools like Next.js would be using Webpack, and they would be creating their own CLI. It's like next build and next serve command. Internally, they will be using Node.js API of Webpack. So now let's move to the core concepts of Webpack. So first core concept of Webpack is entry. Suppose you have an entry browser.js file, which requires a wrapper.js files, which again depends on different files, say app.js or a node module, universe, error service. So universe is actually a front-end tool that we use at Razorpay that provides everything out of the box. Your error service management or your performance monitoring management, which and they again depends on something like Sentry or some CSS or some PNG files. So this is how the structure of a normal code base looks like, right? So the entry is the first JavaScript that kicks off your application. Webpack starts looking at your code base from this file and then builds a dependency graph. So, for example, this is how you will define it in your Webpack configuration. Say entry is source and then path to the file. Here is its source entry browser.js. Then Webpack will go into entry browser.js. It will see that you are importing wrapper, then it will go to the wrapper file, and then error service app, import some CSS. So if you want to visualize your dependency graphs, Webpack offers a official tool. You can go to this URL webpack.github.io/analyze and upload the stats file of your Webpack bundle. It will generate a graph like this. So in this, each module is each dot is actually a Webpack module, which is a file. So this is a good way to, if you want to visualize your dependency graph. So entries basically tells Webpack what files to load for browser, and of course it complements the output property. So next property is output. So we define output in Webpack configuration. Output manages, you can define where to load the generated bundle, where to create the bundle, and what file name should be it. And you can also define other things like the output should be ES module output or ES5 output. So this will create a bundle.js file in dist folder. So output tells Webpack where and how to distribute the bundles. And it works with the entry property. The next core concept is loaders. So loaders tells Webpack how to treat non-JavaScript files. So basically Webpack is created for JavaScript files. It understands JavaScript files out of the box, but there should be a way for Webpack to understand non-JavaScript files, right? For example, we see some CSS files or TypeScript files. So loaders allow us to do that. So loaders are nothing but basically functions which takes one source and returns it in a modified state. So let's say the source would be TypeScript, then the loader would do some modification and return some JavaScript. So the configuration of loader is quite extensible. You can define a regular expression which will tell Webpack to run loader against these files. You can also include or exclude some files which you don't want to run your loader against. For example, a best practice in React development is that you exclude your node modules. You can also chain your loaders. So for example, you have a Sass file, style.css. So you can define multiple loaders for your file. For example, it will go through Sass loader, which will convert it to a style.css file. Then again, CSS loader will come into play. It will convert it to a JavaScript file, and then style loader will convert into something like inline style in browsers.js, which will load all your styles into your browser. So basically, loaders tells Webpack how to interpret and translate files. They return compilations. We'll talk more about compilations in the coming slides. The next and the most important core concept is plugins. So plugins are nothing but objects with an apply method to their prototype. So basically, plugins allow you to hook into the entire compilation lifecycle. So we'll talk more about hooks in coming slides. But basically, if you have a plugin, you can actually tap into multiple instances when Webpack, for example, you want to tap into just before the assets are being optimized, or you want to do something right after the compilation has been done. Maybe you want to print something, you want to send your stats report to some server, all those things. So Webpack has a variety of built-in plugins. So some of the famous built-in plugins are the HMR plugin, the define plugin. So this is basically an example of a plugin. So you define a class, you define an apply method to it. It accepts a compiler argument, and then through compiler, you can tap into different hooks. So this plugin just prints hello world when the compilation is done. So how do we use plugins? So to use plugins, you just require it from your node modules and add the new instance of the plugin to the plugins array of your configuration. And you can also pass additional arguments to the plugin if required. So did you know that 80% of Webpack is made up of its own plugin system? So basically, Webpack is nothing but plugins. So once you understand plugins, you will understand how Webpack works. So plugins adds additional functionality to Webpack's event lifecycle. So let's once put it all together. So we start with a Webpack configuration where we define all of our options. Then the Webpack starts reading the entry points, creates a dependency graph, applies loaders and plugins for transformation, and then it creates a bundle. And when the bundle is created, it checks the output property and then outputs it where you want it to be. Now we have the high-level overview of how Webpack is working above the hood. Now we can dive in and see how things works under the hood. So that brings me to the second part of my talk, which is everything is a plugin. So, but before we begin, let's talk about Tapable. So, any of you who has used Tapable or heard Tapable? One guy. Okay. So, Tapable is a library that creates hooks for the plugins. It is created and maintained by the Webpack team and is the backbone of the Webpack plugin system. So, we maintain it as a separate library. So, any other project other than Webpack who wants to use it can leverage it. So what are hooks? How many of you have used hooks? Actually, you use it almost whenever you used it, that is also a hook. Use effect, that is also a hook. So I don't know why I see a little less hands. So hooks allow other users to get notified of important events and run the other user's code in your application when that event happens. A good example would be the add event listener that the browser exposes. So browser exposes many of those hooks. For example, this hook will console.log, you click me whenever a user clicks. So Webpack exports many of such hooks. So how do we create hooks with Tapable? So the most basic hook that Tapable provides is a synchronous hook or sync hook. So when Tapable suggests exposing your hooks through a hooks property. So you create a class. Here we have created a car class, and in the constructor we have defined a hooks property, this.hooks, and in this we have defined a start car hook. So in case you randomly open a Webpack code base, that will be a plugin file, and in that you can see this.hooks property, and you will be able to see what all the hooks that particular plugin is exposing, in case if it's not documented. So now we have defined the hook, but how do we call it? So let's look at this example. So in this example we have two hooks, car started and radio changed. Now to call a hook, we need to run its call method. So for example, this turn on method, we are calling the car started hook. And in this set radio station hook, we are calling the radio changed hook. So whenever, in case a developer wants to access or run some code when the car is started or the radio is changed, he can leverage these two hooks. So it's not exciting when nobody is listening. So let's see how plugin authors or the consumers of this car class will leverage these hooks. So to tap into hooks or to use the hooks, you run its tap method. So for example, here you can see we have initialized a car instance, my car, and then we have defined when we have tapped into two hooks. So my car dot hooks dot hook name dot tap. And then the tap function accepts two arguments. First one is the plugin name itself. It is used for debugging purposes. So in case you see a Webpack error, there will be a plugin name attached to it. And then the second function is the second argument is the function that you want to execute when that hook is called. So for example, here we are console logging car started. So whenever a user will do my car.turn-on, it will log car started. You can also pass arguments to your hooks. For example, here we are passing radio station. So you can actually do anything with it. Here we are just console logging the radio station. So now we know how Tapable is working, how we define hooks, how we use hooks, how we tap into hooks. So now we can talk more in the Webpack terminology. What are the tappable instances that Webpack exposes? What are the hooks that you can tap into Webpack? How Webpack leverages those hooks? So I'm a little bad at drawing, but basically here I want to explain that to use the compilation hooks, we first need to access to compiler. So when you have access to compiler event, then you will call the compilation hook, compiler.hooks.compilation. And then you have access to compilation, then you can use hooks that compilation property exposes. For example, seal, that is run after the compilation is finished, or optimize hook, which is run just when the optimization of assets is starting, or the before hash. Before hash will, as the name suggests, it will run before the hashing of the asset starts. So these are the hooks that are exposed to plugins authors. So in code, it will be looking something like this. So we have a hello compilation plugin, and you can see that we first are tapping to the hook, compilation hook by compiler, compiler.hooks.compilation.tap, then the plugin name. This compilation hook accepts a compilation property, which exposes the other hooks. So we can tap into various hooks like compilation.hooks.optimize, and then we can do anything with those assets. Here we are just console.log assets are being optimized. So the first tappable instance that we are going to talk about is compiler. So compiler is the top level central dispatch of Webpack. It is the main, you can call it the heart of Webpack. So this is what starts and stops Webpack. So, and it is exposed by Node API, so you can just import Webpack from Webpack and just call it by Webpack, and it accepts two arguments. The first one is the Webpack configuration, and the second is the callback function, which you run after the compilation is done. So in case there is error, or so you can ignore those error or throw an error. Second tappable instance is compilation. So compilation is also known as the dependency graph. It is the brain of Webpack. Everything inside Webpack is happening inside the compilation instance. For example, the building of dependency graph, loaders are being run, plugins are being executed, everything that is happening inside the compilation instance. Then the next tappable instance is resolver. So what are resolver? You all know that whenever you do require.foo.js in any JavaScript file, it will automatically the Node.js resolver will resolve it to the foo.js file, or you can also specify relative parts. But for Webpack, we needed an enhanced resolver, which can do a little more things than the default Node.js resolver. So we have created our own resolver, which is an enhanced version of the default Node.js resolver, and we are maintaining it as a separate project. You can find it under github.com/webpack/enhanced-resolve. So any of those module not found error you have seen in Webpack, those are part of these resolver. So what does resolver do? So it checks if a given path exists in your file system or not. So for example, Webpack encounters a file, reads require foo.js in your code base, so then it will check if this file exists or not. If this file exists, it will return an object which will contain some additional details as well. It will contain the absolute path of the file and the context and some other properties as well. So also it will check if the file is a JavaScript file or a non-JavaScript file. If it is a JavaScript file, it will resolve it. Otherwise, if it's a non-JavaScript file, it will check if a loader is specified against that particular file. If not, it will throw an error. If it does, the request gets successfully resolved. Next is module factories. So Angular also has this concept of module factories. So has anyone here used Angular? Yeah, good, great. No shame in that. So what module factory does is takes one object and returns another object. So what module factories in Webpack do, these take a successfully resolved request which has the full absolute path of the file. It goes through the module factory and then it returns the source code written in that file along with its file name. So basically here is the reading of code be starting. So for example, this file.js, if we have a file.js file, this source property will contain the code inside the file.js file. So after we have read the code, we need to parse it, right? So the next Tapable instance is the parser. So how many of you are familiar with ASTs, abstract syntax trees? Nice, good. Good to see a lot of hands. So now we need to parse. So as the name suggests, the parser will parse. So it will take the source code and run it through parser. Then the parser, after the source code is parsed, it will look at the generated AST. It will find all the requires and the import statements in that particular file and create dependencies or a module. So whenever, suppose you see another import inside another nested imports. So it will create a module at the high level, say entry.js, and it has two other imports. It will attach them as the module dependencies, something like this. The next Tapable instance is template. So template is what a chunk looks like. So has any one of you has actually gone into the bundle.js file and see how Webpack outputs that bundle? Nice. So that is basically the template. So template, you can think it like the JSX you write inside React. Module, you can think like the props you pass. And once that, so we define how we want to create the bundle here. And once the bundle is created, that's the output you see in .bundle.js. So let's recap. So the cycle starts with compiler. Compiler creates a compilation object. The compilation then initiates the resolver whenever a request comes to it. Then resolver resolves the pipe and check if the loader, check if it's a non-JavaScript file, check if a loader is defined against it. Otherwise, it will throw an error. And once the request is successfully resolved, it will pass it to the module factories. Module factory will read the source code and create a module object from the resolved path and then pass it to the parser. The parser will create an AST out of the source code and read all the import statements and create a chunk, pass it to the chunk template, and then the chunk template will do the data binding of the pass module object and create a bundle.js, and it will create the bundle file. So that's it. You just learned how Webpack works internally. That's the high level overview of the architecture. Thank you.